It's Threadripper non-pro build time in a white Meshify case. Meshify 3 to be exact. It's the Arrow D motherboard, and we'll talk about it. We'll talk about all the choices that I made, wrong or right, but I am fairly happy with how this build turned out. Now let's talk about Threadripper versus Threadripper Pro. Threadripper Pro has 8 memory channels, and that is fantastic if you need a system that has a lot of memory, like you're working on AI stuff, or you're using your computer as like your local developer workstation and you're deploying a lot of containers or working on Linux or doing whatever. It's a lot easier to get more memory in the system with 8 DIMMs instead of 4. That said, the upgrade from Zen 4 to Zen 5 in the context of power users is pretty significant. The upgrade is... The Zen 5 cores are much more desirable. Not just because AVX 512 is twice as fast, but a lot of that, heavy load juggling workload is fast. The problem is that you need a lot of cores to use a lot of memory channels. And on Zen 4, the memory speed it supported was up to 5200. Well, we can run 6000 JEDEC or overclock with Zen 5. So it is a pretty dramatic memory speed increase. And in my opinion, that makes it a little less of a performance penalty if you go with a 4 memory channel platform than the 8 memory channel platform, especially if you go for 6000 and even 7200 and beyond. I reviewed a V-Color kit of memory a while back that was quite fast and with heat spreaders. And we tried some 7200 and we tried some 8000. I'm running 7200 in here and I'm running it at the native 7200. So even though this is a 32-core CPU, I'm still able to achieve, depending on which memory bandwidth testing you do, like 300 gigabytes per second. The equivalent 32-core 7 series processor, 7200 was not even attainable in terms of stability, but we're talking like peak 260 gigabytes per second, give or take. And the fact that this is so much faster, even though it's still just 4 memory channels, is very exciting. I love that. It's great. So to see the question really becomes does it make sense to try to run an 8 memory channel platform with only 32 cores to get access to all of the memory bandwidth? And it's tough to do that if you've only got 4 CCDs. If you go 64 cores, then you've got 8 CCDs, because there's 8 cores per CCD on the Threadripper side, and it's a little easier to achieve. If you get the 96 core with 8 memory channels, Zen 5, and you're running everything full tilt, we're talking like 500-600 gigabytes per second memory bandwidth. So it really does scale pretty significantly. That's even more CCDs. If you go to the EPYC side, there's some EPYC CPUs where each chiplet has 2 connections. So you have twice as much bandwidth from each chiplet to the I/O die. It's better able to take advantage of the memory bandwidth. But I'm getting way off track. The Meshify case is really not designed for Threadripper builds in general. And I do not recommend it for Threadripper builds. You get the Meshify 3 XL. It's a much better choice. You're going to have to look at your motherboard, because these big motherboards, it's like eATX, extended ATX, or you got to look at the actual dimensions and look at the actual dimensions that your case supports. The Arrow D is the smallest and least expensive Threadripper TRX 50 motherboard that's out there, as far as I'm aware. And it's also physically one of the smallest, if not the smallest, and it just barely fits in our Meshify 3. And you can take a look at that. You can see in the camera footage and the B-roll, there's a nice, attractive cable hider thing at the front here. This slides. If you're interested in this case, check out our full review on this case. But at the rear I/O, it sits flush. This is a white case aesthetic. The Arrow D is ostensibly a kind of a white aesthetic. And so I think for this build, this makes a lot of sense. And this inexpensive motherboard with the 16, 24, 32 core CPUs can work and get the job done. And 4 memory channels with up to a 32 core CPU doesn't bother me too much unless your play is capacity, as I was explaining before. Now, for the GPU in here right now, I have the ASRock Taichi 9070 XT. This is a really high-end GPU. The only thing I don't like about this GPU is that it takes 3 slots. 3 slots. It's so much room. This Threadripper motherboard only has 3 X16 slots to begin with, and it really crowds the second available X16 slot. This motherboard also has 4 M.2 slots, I think 3 of which are PCIe Gen 5, And our initial, configuration here, this is a 9970X. So, 32 cores, Zen 5. I'm pretty excited for that. I could run high-speed M.2 with the onboard M.2. I could also take the bottom X16 slot or the second X16 slot and break it out into storage. Like, this is an E3 PCIe Gen 5 CM SSD from Kioxia. This is enterprise storage. This is very fast, very low latency. This is excellent storage for workstations if you're working on AI or anything like that. The problem is the interface, the connector. How do you go from this to this? Higher end Threadripper motherboards have a header called MCIO, and so you can use a cable to get from there to this. Companies like ICDock make stuff for this, and so that is maybe also an option. It depends. You have to look at some things and dot the I's and cross the T's. I've used ICDock docks in the past with great success, being able to add them to this. But this is a really low cost Threadripper build, and so because it is a low cost Threadripper build, we're not really going to have any of those kind of options. You're probably going to be relegated to M.2 or used enterprise storage, which we'll talk more about in a second. Now, our motherboard at the rear I/O, if you look at it, there's a couple things to note. It's got a bunch of USB connections. It has USB 4, so this is a built-in Thunderbolt compatible interface, and generally your Thunderbolt peripherals will work pretty well here. This is a storied motherboard because it existed for 7000 series CPUs. There's a lot of threads on the Level 1 Tech's forums that have various people trying to get various Thunderbolt devices to work with this. This motherboard gets like a B- for Thunderbolt 2 peripheral compatibility, but there are folks in the forum that have gotten it to work with audio interfaces, DACs, and all that kind of thing. There's 2 analog 3.5mm ports for audio, line out, and microphone. It has one 2.5 gig NIC and one 10 gig NIC. This is based around the Aquantia 10 gig chipset. There's a stack of 4 5 gigabit USB ports, and then we got a couple of 10 gig ports and a couple more USB 3.2 ports at the top. There's this weird DisplayPort in port. Why does it need DisplayPort in? You can go from DisplayPort on your Taichi GPU out and then in to the motherboard. And what that does is it enables the video channel on one of your USB 4 ports. So you'll be able to run USB and video through USB 4. This might be important to you if you have a USB 4 switching setup. There's some folks on our forum that have a fiber optic, like a Dow Corning fiber optic Thunderbolt cable that they use, and they'll put this machine in the basement, and then they've fished a 50-foot optical Thunderbolt cable through their house, and then they use a Thunderbolt dock with their desktop so that the computer part of it is somewhere else. That's fine. Just remember that Thunderbolt 4 is relatively limited bandwidth. It's only 40 gigabit. So, that's fine for like a couple USB peripherals and like 4K 60. You're not going to be running a high refresh 4K monitor with that. Or if you do, it's going to be a little problematic. And certainly not high-speed USB peripherals plus something beyond 4K 60. That's just silly, but that's why that's there. We also have our Wi-Fi 7 interface on the back. There's this motherboard, I think, launched with Wi-Fi 6, but has since been updated to Wi-Fi 7. So that's nice to see. There's actually a couple revisions of this motherboard. This is the 1.2 version, I think. There's 1.0 and 1.1. So be careful if you're looking on the used market. It's like, you don't want the 1.0, but the 1.1 or the 1.2 is a pretty good version of this board. Also like the design of the mesh PHY case because it scoops air in the front. And that's what I've done for our cooling here. Now, I've gone for a tower cooler as well because that's inexpensive. I don't think you should bother trying to put an AIO in this. For Threadripper, there's only really 1 or 2 AIO options that are amazing that I've tested. One of them is Silverstone, but it's really expensive. This is a Noctua tower cooler, and this is the horizontal orientation. So it's pulling air through the top, and the GPU is doing that as well. It might make sense to add an intake fan on the top pointed in this way so that all of this is going this way. Maybe. Also would recommend not just the Noctua 140mm cooler for SP3. That's what this socket is. I would also recommend Arctic. Arctic has some SP3 coolers. The difference is that the Arctic SP3 coolers are oriented front to back. So if you want a top to bottom cooler, you have the Noctua option. If you want a front to back cooler, you have the Arctic cooler. In terms of actual heatsink performance, the performance is almost identical across probably a dozen systems in our office in empirical testing and lab testing and cross-checking notes with other people. It is shocking how good the Arctic cooler is. I mean, Noctua sets the standard. That is a very high standard to live up to. But Arctic meets it, and in some builds and some configurations can beat it because sometimes front-to-back cooling makes more sense than top-to-bottom. Nevertheless, This cooler will get it done. This even will give you a little bit of overclocking headroom. In this configuration with the glass side, however, the CPU under full load is like 76 to 77 degrees C, which is fantastic for a tower cooler. And as soon as the load goes away, the temperature comes back down really quickly. So that's pretty exciting. And I'm using Arctic MX6 for our thermal paste. For the power supply, for a build like this, 32 cores, 64 cores, mild overclocking, 1000 watts is the floor, 1200 watts is recommended. This is not really a build. I was like, oh, I'll do a dual GPU build. Nah. You can do it with the Aero D, but I don't know that I would recommend it. The one exception to that is if you're going to go for these new Radeon AI Pro 9700 GPUs. I reviewed this separately. These are 32 gig GPUs. The retail on these is about $1,300. $1,300 for a 32 gig GPU is fantastic. Two things. One, AMD has dramatically improved their creative drivers. So the performance in things like the Adobe Creative Suite is about 70 to 80% as good as a 5090. But this is at less than 50% of the power target and still has 32 gigs of memory, so the same VRAM, and about half the cost of a 5090. So 80% of the performance for half the cost, same VRAM, and about half to 60% of the power budget. That is pretty impressive. But that's not really like the whole story with these cards. The rest of the story with these cards is ROCm and RDNA and using these for AI. You can put two of these in a system. This particular Sapphire version of the card only takes 2 slots. And in this system, that works really well, even with the Aero D motherboard, because there's adequate breathability between the cards because of the physical placement of the PCIe expansion slots. Now, I've gone a little off-label with my storage. I'm using a M.2 on the back here. But because this motherboard is one of the Threadripper motherboards that does not have, MCIO or SlimSAS type connection on board, I have to use a special M.2 adapter, which adds to the expense, which is, I really wish the Gigabyte had put an MCIO connector on there, but hey, it's the least expensive Threadripper motherboard you can get. That works fine if you have like the U2 or U3 version of this. You can also get a different kind of adapter to go to E3. Just depends on what sort of enterprise storage you want. Now let's talk a little bit more about that off-label storage thing for a second. It's perfectly okay to look on eBay and corporate surplus and roll up your sleeves and get your hands dirty. If you look at Threadripper motherboards, sometimes you might fall into a trap where the header says, oh, it's a SlimSAS type header. It doesn't signal SlimSAS. SAS, Serial Attached SCSI, is an enterprise protocol. You normally need a SAS controller in order to do it. This is a really inexpensive Inspur SAS controller you can get on eBay. They're usually like $10 to $30. This particular one is SAS 12. SAS 12 can do 1.2 gigabytes per second per channel. This is an 8-channel card. Enterprise storage that's SAS is really cheap, and sometimes it's absurdly cheap. Sometimes I do a video on this kind of stuff and it gets less cheap. Sorry. But like 4 to 8 terabyte drives are usually on the order of about $50 a terabyte. You can find it as low as $25 a terabyte, especially if you go as corporate surplus as opposed to things that are sold online. Server part deals. I've bought a lot of stuff from server part deals. This is not a sponsored ad for server part deals. I just buy things in that. And it's like, oh, they've got a good deal. Macroeconomic conditions and the tariff and the import situation have driven prices up a lot, but sometimes they do have really good used enterprise stuff that they've checked out. And so check them out because you might be able to find a deal. Anyway, I got a PM1633. This is 4 terabytes. I get this for $170. So this isn't too bad. And this will hold a lot of AI models. It's thick. It's 2.5 inch, but it's really thick. The performance on these, not fabulous. This also, the reason it's cheap, it doesn't work if you just plug it directly in. So this is a cable that you'll need. This connector looks like it's SATA with power next to it, but it's actually solid. Whereas a SATA drive, it has a notch and you have 2 different cables. But with this kind of a thing, it has to go into a backplane in a server, or you have to get one of these SAS cables. They're about $12 each. This one cable has 4 connectors because it'll support up to 4 drives because it's 4 lanes. And then with that connected to our controller, connected to our drive, we can connect up to 4 8, 16, 32 terabyte drives to this one controller. We can put this in the bottom slot, and as long as I've got pretty good airflow through here, it'll stay cool. These cards are designed for server airflow, so you might not get enough airflow in a desktop case. They should not get super hot. You shouldn't let them get super hot. But if you keep it cool, then this is a perfectly reasonable storage solution. And depending on what age of SSDs you get, those SSDs will do 1.2 gigabytes per second. So they're twice as fast as SATA 6. Now, this is true SAS signaling on a SAS cable. The other SAS connections that are on Threadripper motherboards, it shares the connector, but the signaling protocol is different. And I want to call that out because this is something that has come up on our forum, and people have made that mistake. It's like, oh, I thought it had a slim SAS connection. I could just use it. Well, it's the same family of connector, but it's actually got PCIe over it. You see, it's not a coincidence. Well, I mean, it kind of is, that these connectors have 4 channels, and most NVMe are 4 channels. And so if each one of these were just a PCIe lane, 1, 2, 3, 4 gigabytes per second, that you would get from a PCIe Gen 3 storage device. Is it clicking? So this can be an off-label way to add secondary storage. I don't recommend this for a boot volume or like a primary volume or anything like that. But if you just need a lot of fast flash, relatively fast flash storage to store AI models or something like that, this is a great way to thread the needle without spending the money to get something that it is like legit bananas. This is really good for the money. This is legit bananas. That's the difference. And you can do that even with a low-cost Threadripper build, but I think this is a much bigger bang for the buck, especially if you're building a system like this, because you're getting, the retail current motherboard, retail current CPU, retail current memory, a reasonable M.2. What M.2 might I recommend? Corsair has a pretty decent Gen 5 M.2 that I reviewed recently. The Crucial T700 series M.2, I've reviewed those. Those have been fantastic, and can deal with the write level and all that kind of stuff. Some of the other M.2s that we've reviewed recently, generally, I'll call it out if there's something about it that is not ideal. Understand, though, that the wear endurance of this thing far, far outstrips the wear endurance of modern M.2. This thing was built like a tank. And so, yeah, it's slow. It's only 1.2 gigabytes per second, but it'll work until the cows come home. Whereas modern M.2 are not necessarily designed for constant rewrites. No, there's drives that are better and there are drives that are worse. And so, the Phison controller-based Corsair M.2 is generally higher quality media with a higher clock, and it has pretty reasonable endurance, on the order of half of a drive rewrite per day. In 5 days you could write 10 terabytes to it, and that is within the wear parameters, all the way up to 1 or 2 drive writes per day. Whereas SSDs like this are designed with much higher endurance in mind and really dot the I's and cross the T's on that level of reliability. But if you're using it as a boot volume and you use these as data, it's the best of all worlds. So it works out pretty well for you. I'm going to give you a pro tip if you're going to use the enterprise storage stuff too. This SSD will not turn on if you give it 3.3 volts. So if you just connect a normal SATA style power connection to this drive won't show up. It's dead. It doesn't work. Ketchup and mustard. The reason it doesn't work is because you're missing ketchup and mustard from your build. So this is Molex to SATA. This only has 5 and 12 volts. It does not have 3.3 volts. If you use this adapter to go from the 4-pin Molex style connection to the SATA style connection on this adapter, then it'll work. Also, be careful when you're buying these adapter cables because you want the ones that have the power part built in. Sometimes you get these and it looks like it has a SATA style connection. Don't get that kind of cable for this because this is the kind of cable you need when you're going to attach SAS type drives as opposed to SATA. That plus your Molex 5 and 12 volt only power cable, that's what you need. In a pinch, you could cut the 3.3 volt wire from your power supply. I'd feel less bad about that if it's a modular power supply cable, but I didn't tell you to do that. This is easier. Just order a couple of these. They're like $1 or $2 each. For the GPU, yes, you can go with an NVIDIA GPU. That's not a problem. Our Tai actually has the 12V2 style power connector. Our Sapphire GPUs have the 12V2 style power connectors. You can run 2 of these off of a 1200 watt power supply and still have enough room for the entire rest of the system. If you wanted to build a system like this to run off of 2 Founders Edition 5090s, you're going to need a 1600 watt power supply. And if you're going to spend that much, like dual 5090s and on up, you probably should get a motherboard that has more PCI Express expansion slots. If you want one specifically from Gigabyte, you can check out the AI Tops motherboard, which I think is a pretty good motherboard. It's a pretty good balance of all features. It's just a misunderstood motherboard because people try to use 8 sticks of memory with non-pro Threadripper processors. I did a whole video on that. But and then there's other options. The ASRock TRX50 is a favorite, as well as the Asus Sage TRX50. Those are all great boards to build your system around, and they have different enough features that they're differentiated from themselves in the market, in my opinion. For the power supply, I'm sticking pretty much right now to ASRock, FSP Group, and Silverstone. Those companies are making ASRock in particular because they added a temperature sensor to their power supplies. And so you can get a power supply that has a temperature sensor in the 12V2 connector. And so if you want advance warning that something is going wrong with the 12V2 connection, you've got it. But FSP makes server power supplies, and they also make desktop power supplies. And so I'm very happy with FSP in the context of server power supplies, and so I've been trying them out in builds and systems that we have around here at the office, and so far so good. I also really like Silverstone. Silverstone makes enterprise, like high-end stuff and stuff that you just want to set and forget about it, and their power supply has been fantastic for supporting dual RTX 6000 and dual 5090 builds without any trouble at all on a standard 120 volt North American breaker, which is awesome. So there you go. If you don't like brown Noctua fans, you can get black ones now. And it just barely fits in the case. There's like 2 millimeters of clearance. I'm really happy with how this build turned out. I would probably add another fan, maybe an intake on the top right here would help. Maybe. I don't know. It just depends on my temperatures. So far, my temperatures have been fine. Fractal's got a certain aesthetic. And I like the surfaceability of the case. It'd be nice if you could permanently attach the top somehow. The top is always removable. You can screw in the side panels, so you can prevent the side panels from popping off, but really doesn't seem to be a way to do that with the top. So there you go. Those are the components. That's why I chose them, and that's how this build turned out the way that it did. If you decide to do a similar build, or this inspires you to do a build, share some pictures or something with us in the forum at Level 1 Text. I'm Wendell, signing out, and I'll see you there.